Here are some examples from the day 55 assignment. We're dealing with number sets here. So they say that set A is the factors of 12. So, okay, so let's write that down. Factors of 12 are 1, 2, 3, 4, 6, and 12. These are all the numbers you can divide 12 by. Set B is a set of even natural numbers. Now, natural numbers are counting numbers, so that means you start at 1, not at 0. So the set of even natural numbers less than 13, so that's 2, 4, 6, 8, 10, 12. Has to be less than 13. Set C is odd natural numbers less than 13. So now starting at 1, 3, and it said less than 13, so we don't go up to 13. So 5, 7, 9, and 11. And then set D is the set of even natural numbers less than 7. So that's a subset of B. So 2, 4, and 6 would be the only ones there. All right, so what is A union B? So, sorry, intersection B. Oops, intersection B. That's the upside down U. So what is the intersection of A and B? What are the ones that A and B have in common? So I see there we have, they've already done the braces for us. So let's just write the numbers. They both have a 2, a 4, a 6, and a 12. So 2, 4, 6, 12. I don't put any spaces between the numbers. This is the same thing. Let's see. A is instead of writing everything down, let's just skip to the question. They want A union B, so I'm just gonna write A and B here. So A is a set of factors of 12. So 1, 2, 3, 4, 6, and 12. These are the numbers you can divide 12 by. And B is the set of even natural numbers less than 13. So that's 2, 4, 6, 8, 10, and 12. So A union B means now if you see it, you have to write it. Every number that's there has to be written. If you see it more than once, though, just write it once. So A union B. So that will be 1, 2, 3, 4, 6, 8, 10, and 12. No other numbers there. Okay, what is the A complement? So in order to have A complement, we need a universal set. My universal set is the set of natural numbers less than 13. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. That's my universal set. Set A is the set of factors of 12 still. So 1, 2, 3, 4, 6, and 12. So A complement is all the numbers that are in the universal set but are not in A. So we would start that with 5, then 7, then 8, then 9, then 10, then 11, and that's it. You have 10 cards, numbered 1 to 10. You choose a card at random. Event A is choosing a number less than 6. Event B is choosing an even number. Calculate the probability of A. So this is just simple probability. Event A is choosing a number less than 6. So the numbers less than 6 are 1, 2, 3, 4, and 5. The more important thing is that there's 5 of them. And if there's 10 cards in total, then that simple probability would be 5 over 10. That now, as a fraction, that can be reduced to 1/2. A lot of times they'll let you put it in as a decimal also, would be 0.5. I'll just try putting it in as a fraction. You have a set of cards from number from 1 to 10. They want to know now what's the probability of A union B. Okay, so let's see. A is choosing a number less than 5, so that's 1, 2, 3, and 4. So B is choosing an odd number from 1 to 10, so that's 1, 3, 5, 7, and 9. So that means A union B would be 1, 2, 3, 4, 5, 7, and 9. And more important than what the numbers are is how many there are, because now if I want that probability, there are 7 elements in the union divided by 10 cards in total, so that's 7 over 10. That cannot be reduced, so I'll leave it as 7 over 10. You have a set of 10 cards, numbered 1 to 10. You choose at random. What's the probability here of A intersection B? So set A is choosing a number less than 4. So that's 1, 2, and 3. B is choosing an even number from 1 to 10. That's 2, 4, 6, and 8. Sorry, 10 also. 10 has to count. 2, 4, 6, 8, and 10. So the intersection, those elements that are part of both, that's only 2. A intersection B is just the 2. So there's only, you don't write 2. You just, the fact that there's one element means that you would then be, the probability it would be 1 out of 10. 1 out of 10 cards meets that criteria. Okay, what's the probability of the complement of A? So here my universal set are all the cards from 1 to 10. Event A is choosing a number less than 8. So that's 1, 2, 3, 4, 5, 6, 7 is less than 8. So that means that a complement, if the cards are from 1 to 10, would then be 8, 9, and 10. There's 3 cards there, so 3 out of 10. 3 out of 10 would be the probability of the complement. We also learned that this could have also been calculated by doing 1 minus the probability of A. I could have also done that also, 1 minus 7 over 10, which would have given me still 3 over 10. Using the complement of the event, use the complement to find the probability. So you roll a 6-sided die. What is the probability that you do not roll a 3? So the probability of 3 complement would be 1 minus the probability of getting a 3. Well, the probability of getting a 3 is 1 out of 6. So 1 minus 1 over 6, and if you were to do LCD and all that stuff, that would give you 5 over 6. There are 5 sides of the die that are not a 3. Use the complement of the events to find the probability. You spin a spinner shown. The spinner is divided into 12 congruent parts. What is the probability of not spinning a 5? So we'll use the probability of 5 complement is equal to 1 minus the probability of getting a 5. So that's equal to 1 minus. There are 1, 2, it looks like 2 5s. So 2 out of 12, which that's the same as saying 1 minus 1, 6, so yet again we get 5 over 6. Probability is 5 over 6. Using the complement, use the complement to find the probability. A bag contains 2 red, 4 blue, and 4 green balls. what's the probability of not choosing a red ball? So probability of red ball complement is equal to 1 minus probability of red. Whatever, red ball, same thing. So that's going to be 1 minus, well, there's 2 red balls out of 10 balls in total, so that's going to be 1 minus 1/5, which is 4 over 5. 2 over 10 reduces to 1 over 5. A standard deck of cards has 13 cards in each of 4 suits. The hearts and the diamond cards are red. The clubs and the spades cards are black. If you choose a card from a standard deck at random, what's the probability that you do not choose a club? Okay. So there is 13 cards of every suit, including clubs. So if I wanted to find the probability of basically they're saying the complement of a club, it's 1 minus the probability of getting a club. So that's 1 minus, there are 13 clubs out of 52 cards in total, or since you knew that there was 4 suits, you could have just said 1 minus 1/4. If you do LCD, that gives you 3/4.